So what we are going to do is, this is the solution to the queues problem. So what were you given? You were told that you should use the queue ADT that is given, and basically what we are looking at is you are expected to create 3 different queues. So it's like a doctor's clinic, and there are severe cases and there are non-severe cases and there are moderate cases. So what is done is 3 different queues are created. Obviously the people with severe problems have to be treated in greater numbers than the moderate people, and the persons with not any severity at all can be treated the least. But at the same time, what you cannot do is, if there are many severe people, you cannot only treat severe people and not treat the people with moderate illness and the people with very less illness, right? So otherwise people will get tired, they will not go to the doctor at all. So what was suggested in this was, you create a 4th queue to the doctor. So let's say there is a receptionist at the desk where you go and register your name. The person listens to your complaint and realizes whether it's severe, moderate, or what you call basically what it does is, it looks at your priority. Is your priority 1, is your priority 2, basically depending upon the severity, and depending upon the priority it's supposed to put you in, once the person identifies what kind of severe disease that you have, depending if your priority is, let us say, very high, then it's severe, it goes into the 1st queue, and if your priority is not so severe, it goes into the 2nd queue, and that's exactly what is done. And so basically what you're doing is, you're taking as input a token and a priority. If priority is equal to 1, it is put into the 1st queue. Priority is equal to 2, it's put into the 2nd queue, moderate, and priority is 3, not so severe, not at all severe, so you go into 3rd queue. And what does the question say? It says this doctor's queue, and what you should ensure is that there are 10 patients in the queue, doctor's queue for example, at any point in time. You are allowing 10 elements in the queue. So what you do is, the way you allot them is that first you put 3 patients from the high priority queue, then you put 2 patients if they are there from the moderate queue, and then put 1 patient from the least moderate queue, and you keep repeating this order. So that, for example, if there are, let's say, 6 people who have severe problem, then the first 3 will get served, then the moderate person will get served, 2 moderate people will get served, and then 1 person with non-severity will be served, and again the 3 people with severity will be served. Okay, that is the application. And what are you supposed to give? You are supposed to output the elements in the queue. Okay, so let's look at this program as it runs. It's a very simple problem on queues, which we have already studied. It's not really a priority queue. What we are doing is, remember the queue that we studied in the class, for example. Most important point here is that if you look at Q1, Q2 and Q3, people enter the queue. What's happening is, first come first served they are, in the sense that for that particular list. Okay, that is, with a particular severity, if you come, you go into that particular list. If the next person who comes into with a particular severity, then you go into the same list, but at the end of that queue. Okay, that's exactly what we are having over here. All right, so let's run this. What are you given? You're given a token and a priority, right? So let's say 10, 3, 11, 1, 22, 2, 23, 1, 24, 2, 25, 1, 26, 3, 28, 3, let's say 33, and 43, 3, because normally you will have people with low priority. Okay. Now, what is it giving? So number 1 means token and priority here. So basically, if you notice, there are 11, 23 and 25, 3 patients who are having severe problems. So, the doctor's queue has 11, 23 and 25, the token numbers of these people. And then what happens? There are 2 people with lower severity, 22 and 24. So, the next 2 guys go over here. And then what do we have? The rest of them, because there are, ideally you are supposed to allow only 1 person with low severity. But since there are no other patients with higher severity, it goes into this particular list. Let us run this program again. Let us say we have 10, 3, 11, 3, 22, 2, 23, 1, 24, 2, 25, 1, 26, 3, 28, 3 and 29, 3, 33. Now, what happens here? So, you have basically we have we still have only 6 people over here. 1, 2, 3, 4, 5, 6. Okay, that's okay. We have basically 2 people. Okay. So, 23 and 25 are high priority over here. Then, since there are nobody else with higher priority, 22 and 24 come, and finally all the other people. Okay. So, this is about using the queue ADT which was defined and using it to create 3 different queues. Remember, this is not the priority queue. It says that every queue is a first in first out queue, but there are 3 different queues, but you create what is called a 4th queue which corresponds to the queue of the doctor, in which we put elements into that queue depending upon the priority. Okay. So, this is something that you need to understand, and this shows the execution of the program. And what are we showing here? We are giving the token numbers of the elements in the doctor's queue. Okay. So, now we will look at a solution to another problem, which is the postfix evaluation problem. We already saw the infix to postfix conversion. Okay. So, let us look at this postfix evaluation problem. This uses a stack, and here in the remember when we did the infix to postfix conversion, we were given an expression, and we said the expression has to be converted to postfix. So, when we did that, what we did was we defined a stack of characters, if I remember right, of some particular element type, and in that case what we did was, why did we define a stack of characters? Because in that problem we put the operators onto the stack, and as soon as you came across an operator which has lower priority than what was there on the stack, lower or equal to priority, we popped all the elements out of the stack. Now, this is a slightly different problem. You are given a postfix expression, and what you are supposed to do is, let me take this example over here. So, what we mean by this is the following. In postfix evaluation, okay, let us look at this problem here. So, we want to add some integers, okay, in the postfix evaluation problem. So, let us say I have the numbers -4, 50 plus, and this is one token, and 6 and star, 6 plus let us say 4 plus 6 and star. So, this is a postfix expression. So, now I am putting these boxes around all of this because I can't treat them as simply a stream of characters, for the simple reason that the integers, for example, when you look at them in terms of characters, depending upon the number of digits that they have, can have more than 1 digit, like this example over here. So, what are we expected to do in this? We notice that this -4 is a number, it is a unary minus over here. So, it is given as a number here. So, I want -4 plus, so what I do is, I want to use a stack to do this problem. So, what do we do here now? How do I do this now? The way it works is like this. As soon as you see an operand, you put it onto the stack. Okay? Now minus 4 is an operand, I put it onto the stack. 50 is the next operand, we put it onto the stack. But as soon as you see the operator, what you do is, this is operand 2 and this is operand 1, and you perform operand 1 minus plus operand 2. Okay? So what we do is, we first pop off both these elements. Okay? So let's say I put OPND 1, 2. First element that's being popped is 50, and the second element that's being popped, OPND 1, is minus 4. Then you perform OPND 1 plus, because I've seen an operator here, OPND 2, and then minus 4 plus 50 is 46. Let's say this is the result, and this is equal to 46. So since we have popped both the elements, the stack is again empty. I push 46 back onto the stack. Okay. Then what do? We have, now this is done. Come to the next token, I push it onto the stack because it's an operand. Then again I see a plus. Therefore again now OPND2 equal to 4, OPND1 equal to 46, and the result is, so I pop both of them out, so again my stack is empty. Then add these two numbers and then push it back onto the stack. Okay? So I push that back onto the stack. Then what do? Next time here, I've already finished the operator here, I push it onto the stack. Okay? Then I see a multiplication, right? Now what do I expect? So basically the OPND2, 6, OPND1 is 50, and we do multiply the two of them. The result is 300, push it back onto the stack. Okay? Now we have come to the end of the expression. So I pop the element of the stack, and that is the result. Okay? So that's exactly what is being done in this part of the problem. All right. So what is being done is here, if you notice, there is an int stack of a particular size that has been implemented, and you push the element onto the stack. But remember that, what is this element now? The element that are being pushed onto the stack are of type integer. Remember, this is an integer stack. Okay. But what are we doing when we are, so basically, and here is something, a result which will compute depending upon the operator, it will compute multiplication, and notice that as soon as we get the operands which are popped off the stack, it computes the operation and returns the result. Okay. Then here is a function which converts a character string to an integer. We will see why this is required in a little while. Okay. And basically you have to take care of the sign and so on and so forth. Then remember, we are looking at tokens there, right? So it looks for a token which is purely an operator, and that is what is being passed over here. Now let's go to the main program here. What are we doing? We are defining a character array called postfix, which consists of a string of integers. Why are we doing this? Because remember that when you look at a postfix expression, there is an integer here, there is an integer here, but there is an operator here, but I want to give this string as it is. But as we already saw, as I explained some time back, clearly each element in the postfix string is not a single digit number. It can have multiple digits. So what we do is, we represent each one of the tokens. Okay? We call these tokens in the postfix expression. There's token 1, token 2, 3, 4, 5, 6, and 7, each one of them as a string. So to do that, what is done is a character array, okay, of n. Suppose first what you do is, you get the number of tokens in the string. So what is it we are saying here? How many tokens are there? 1, 2, 3, 4, 5, 6, and 7. So 7 tokens in this string. So what it does here, you here for example, the input n is given, and then it creates a number of such character strings which are of size n. And then what does it do? It assumes that the string is no more than 5 characters long, and then what it does, it so there is an allocation that is done here. The string is read and it is put into this postfix array. So what is this postfix array? It's actually a 2-dimensional array, and what is it having? If you look at the 2-dimensional array, in the first element is 4, second element is 50. That is, each element of the array is a string of length 5. Okay, 5 characters maximum. Okay, plus 6 and star in this particular example. So this is the postfix array. And then what is done? Once you have done that, it's basically going to call. Okay, then what is happening here? We need to perform this evaluation. Okay, so what is done is it looks at what the so what is it doing here? It gets each one of the elements that are there in that. There are, as I said, there are n tokens, and for each one of the tokens it checks whether it's an operator or not. Otherwise it pops the elements from the operator, from, for example, V2 and V1. This is operand 2, this is operand 1, and then performs the operation. Okay, then what does it do? Once it evaluates it, evaluation is the result here, it pushes it back onto the stack. So when it's encountering an operand, for example, because it's also a string, it converts the character string to an integer and pushes it, and then pushes that onto the stack, because the stack is a stack of integers, because we don't need anything other than a stack of integers, because we're putting the operands onto the stack. So let's see how this program runs now. Okay, so postfix final, I have to give 7, because let's say I looked at 7 operands here, minus 4, 50 plus 4 plus 6 and star. Okay, so what is it doing? It's pushing minus 4 onto the stack, pushing 50 onto the stack. It encountered an operator next, as indicated here. Then it gets the results 46, it pushes it onto the stack. Then it sees an operand again, pushes the operand onto the stack. Again it encounters an operator. Then what does it do? It computes the sum of, pops both 46 and 4 from the stack, adds them, gets the result 50, pushes it back onto the stack. Then it encounters an operand again, 6, it pushes it back onto the stack. Then it encounters an operator, and what does it do? It pushes once it encounters an operator, it's going to pop 50 and 60, 6 first and then 50, and then perform the operation of multiplication. The result is 300, and it pushes 300 back onto the stack. But clearly by now we have come off to the end of the expression. N has been exhausted, the 7, therefore it gives you the result. Okay, so this is how the postfix evaluation program can be implemented. For those of you who have perhaps not done it properly, I would encourage that you go back and try it out again.